Hey, so I'm here with Changping Chen, who is a summer intern for us here at Meteor Development Group, and you've actually been part of the Galaxy team working on product enhancements and improvements to the architecture. So I'd love to get your take on what you did over the past summer, like what product enhancements you worked on. So maybe let's start with that. What kind of a summary level, what did you do here? What did you work on?
Yeah, so in my 2-month internship, my main project is to make a microservice within the Galaxy infrastructure.
Okay.
The service is called Image Builder, and it builds customers' code into Docker image that we use to deploy containers.
Okay.
A side project is also I improved how we store encryption keys.
Okay. Cool. So for the image builder service, right? What were some of the driving kind of factors or enhancements that led this work? What benefits did our customers of Galaxy see?
It used to be the case that we run all customers' apps on the same Docker base image.
Okay.
And this is a single image that we use for every application. And when we actually when we start a container, we have to go through the build phase, like running npm installs for our Meteor applications.
Yes. So what you're saying is that because we have this enhanced image builder service, now the steps like npm install and all these things that come up that happen at the start of a container bringing up with an application image, we don't have to repeat it every time you bring up a container, right? We can do it once when you deploy the app. You do it once, you build the image, and you store that built image, and then are able to process it and roll it out when containers get new containers. You scale up containers, right? So a user can go and click on the plus button and scale up containers. That makes sense.
And also when container restarts, that'll be using the built images as well.
So if for some reason, we do in Galaxy, we do updates every 2 weeks, or we'll do an infrastructure update, right?
Yeah.
In that case, then the apps that get restarted much quicker than they did before.
Yes.
Fascinating. That makes a lot of sense.
And also improve the reliability of running containers, because now that if you run the build phase, when the container starts, then there's a chance that maybe some of the external services that the build phase relies on, such as npm services or GitHub, might be down at that point, and then containers would have a hard time building and starting. Whereas if you move it all of that and then do it only once before running containers, then all of this is cached and we don't have to do it again.
So if your container fails for any reason, needs to be restarted, you don't have to go through the entire build process just to when your container restarts and starts up, which probably shaves tens of seconds, in some large apps,
some cases,
minutes,
a few minutes.
Potentially. Yes. Awesome. Okay, that's really valuable, and this is something that we rolled out just last week.
Last week. Last Thursday.
Awesome. So in building this, right, there's a set of technologies here that I understand that our engineer team has built Galaxy on. What is the role of Docker in this kind of architecture that you built up? What does Docker provide, and why do we use this?
Yeah, so Docker provides a really nice abstraction for running containers. So it has a lot of APIs for handling images. It has Docker push and pull command that allows us to store and retrieve precompiled images. And it has, of course, the Docker run command, which allows to very easily spawn up new containers with using some images. And we also rely on Amazon's Elastic Container Services.
So we're built on Amazon, right?
Yes.
Yes.
And which talks to Docker services nicely and allows us to orchestrate containers very easily. From one place.
And we use that in the image builder, and we use it in other areas of Galaxy as well, right?
So Elastic Container Service is used to actually run the apps. Whereas when we build it, we don't rely on the Elastic Container Service. We just do a local instance of Docker. And make an image there.
It's probably for performance and reasons why we'll use that in some cases and lots of considerations.
So for build services, we don't run a container for a real long period of time.
I see.
So it's only for spawning new temporary containers that we run for a few minutes, in which we do a lot of npm install kind of stuff. And once it's done, we tear down the containers and we pack it as an image before we send it off to a private registry where we store all customer images.
And then this is a private registry for Docker containers, Docker images.
Yes, so we have a private Docker registry that's running on multiple Amazon instances. And it's load balanced by a Elastic load balancer. And
this is also
all of
an
this
Amazon
is
service,
internal.
right?
All of this run on Amazon and is internal within Galaxy infrastructure.
So this is supporting infrastructure that runs our customers'
Yes.
applications on Galaxy.
Yes.
Yeah. Okay. Okay. And this is all the stuff that you've pieced together as part of the solution architecture for the image builder.
Mm-hmm.
Fascinating. So let's talk about the internship. This is overall internship experience, right? How did you get to find out about Meteor in the first place? I know you go to MIT. How did you learn about Meteor?
Yeah, so I wasn't sure where I was going to intern at last year.
Okay.
So of course, like any other MIT student, I went to the career fair.
Uh-huh.
And then Meteor was on the first floor, I remember. It had a pretty large booth.
Yeah.
And then I went there, and then I met one of the former engineers who worked on Galaxy.
Okay.
And then he introduced me to the team where we had a really nice dinner, and we talked about interesting technical challenges that Meteor faces. And then that's when I decided that this is a really good technical fit for me, and that's why I joined.
Awesome. That's great to hear.
Yeah.
In terms of what you learned here and what you kind of your takeaways from a technical and process perspective, what would you say you take away from this internship that you didn't have when you left college after your junior year?
I think the main takeaway for me from this internship is that running production services was really hard.
Yeah.
In class projects, what we usually do is we aim for a deadline, which is usually the end of the term, and we try to come up with a sort of like a proof of concept of things that sometimes work, sometimes doesn't necessarily work.
I can remember
but the only goal is to make it run once, and then we don't really look at it anymore. But in production services, what you need to do is continuously maintain a service, and we have to think about how customers interact with it and make sure that when we run transitions, the customer experience is not affected, and that is really hard.
And what makes that hard?
What makes it hard? Because rolling out new services has certain uncertainties. Sometimes you only experience bugs that exist in production environment. Like for example, when I rolled out image builder services, we saw problems with how Amazon elastic block storage, which is like a remotely attached, network attached block devices.
This is for storage for those devices?
For all the EC2 instances that we run. So it has, its performance is not necessarily steady after a few hours of continuously writing to the disk.
So that's something you don't really know.
That's something that you usually not see in the dev environment just because of a small sample size. But we quickly mitigated that by moving Image Builder to different type of instances that has local SSDs attached to the physical device.
Got it.
So
working with other professional software developers in a professional software development team is also different from projects, right?
Yeah,
you have. What are some of the kind of learnings or takeaways there that you got working with a professional software development team building a product?
Yeah, so I mainly work with David Glasser, one of the core engineers working behind Galaxy at Meteor. He's been super helpful, he's super smart, and then very meticulous and always catches very little details that I would not have think of. It's a lot of moving pieces. A lot of it is you have to understand how components sort of interact with each other and understand that how your change, even though it looks very innocent, within the scope of the thing that you worked on might have impact on other services as well that's running the same infrastructure. And that's something that requires a lot of thinking, a lot of like deep understanding of how everything works together, and something that I think is not easily learned in a school environment.
So in college, what were some of the courses or projects you did at MIT that helped you out with the projects and the stuff that you worked on here? Can you think of any?
Certainly the general algorithm classes really help. Just like understanding of how like basic data structure, how they function, and what's the expected behavior. I think one thing that really helped is performance engineering class at MIT. It's a pretty intense lab class, which requires you to compete with other classmates and try to optimize your programs. Cool.
Well, Changping, it's been really awesome having you on the team and working with you. And so good luck with the next year at MIT. And thanks for taking the time. Okay.